This is another paper one question, another programming question. Essentially, it's about a very simple game of battleships. So this particular video is just the first part of this. So we've got a single dimensional array here, which has got 0 to 14 spaces, so 15 spaces. And like battleships, we could place ships in different positions. And it tells us that each value in the array is either 0, 1, or 2. If it's 0, it's an empty location. If it's 1, it's a ship, but the ship's not been hit yet. And if it's a 2, there is a ship and it has been hit. So there are those three numbers that can potentially be in the array. So don't be put off by the black and white squares here. They don't really mean anything as far as we're concerned. We could talk about this being a ship, but it doesn't mean anything really to us in this question. So then the first bit of the question is here. So it says the developer identifies one of the subproblems and creates the subroutine shown in the algorithm below. So this subroutine is called F, and it takes us two parameters, the board and the location. And then it's using a variable called H. H gets the value of board at location. So if location was 2, then we'd be looking at the array at 2 here. So if H is equal to 1, then return true. So 1, remember, was if a ship at the location is there but it's not been hit. Otherwise, return false. So we're looking for ships that have been hit, not been hit yet. So number 1 is this a ship that's not been hit? So what we're going to send back from this routine is either true or false, depending on whether there's a ship there and that ship has not been hit yet. So H might have been hit or something like that, and F potentially fire or something like that instead of F. This is a turn, basically. We're firing to see whether we've hit a location correctly or not. So the first question on this is just about data types. Question A. So the data type for true or false we know is Boolean. It's a Boolean data type, 2 options only, true or false. And then the value is 0, 1, 2. They're whole numbers, so it's going to be integer. We've got 2 nice marks for that. So then part B says the developer has taken the overall problem of the game Battleships and broken it down into smaller subproblems. What's the technique? So it's done something like this and split down the big whole game into lots of different little modules. And this technique is called decomposition. So that's just a bit from when we did algorithms, we talked about decomposition, we talked about various ways we could do that. One of those ways being splitting things up into subroutines like this. So part C, the identifier for subroutine F is not a very good choice. State a better identifier. Well, let's say fire, or is it a hit? Even anything like that is fine. And the explanation is, this is a turn to see if a hit has been made or not. So if a hit's been made, then it's going to return true, and if there is no hit, it's going to return false. So that's a reasonable explanation, I think, for that. So then the last bit, and the last one on this bit, is the variable H, not a very good name again, in the subroutine is local to the subroutine. So 2 properties of local variables we need to state. So local variable is only accessible inside the subroutine. So it's local to that subroutine, so we can't access that variable h outside of it. And we could say also that the local variable doesn't exist, does not exist outside of the subroutine. So the actual local variable, it's made in the subroutine, it's actually destroyed, it disappears, it's not there at all as soon as the subroutine is finished executing. So it doesn't exist outside of it. So it's not accessible, and it's not accessible because it doesn't exist outside of it, outside of that routine. And that's a 2-point answer for that one. So the second part of this question, write a program. It's the Battleships Program. So we've got a single dimensional array that's got 15 spaces. We have in it a carrier that's got size 3, a cruiser that's got size 2, and a destroyer size 1. So there are actually 6 areas to hit. So in the board array that we've got, or a list in Python, has got 0, 1, or 2 in each location. 0, it's empty. 1, there's a ship there, but it's not been hit yet. 2, there's a ship there and it has been hit. So we need to develop a subroutine that works out how far away the game is from being over, so having all the ships hit. So the subroutine needs a sensible identifier. So we could call it, let's call it how many hits. That should be okay. So it's a Python definition, how many hits, and it takes one parameter, which is the board, and it says that here, takes the board as a parameter. So then what we need to do is to work out and output how many hits have been made. So we're going to need to know how many hits. So let's have a variable called hits. And we're probably, for the next bit, going to need to know to be hit. So things that have not been hit yet. So we'll make that 0 as well. So then we can use a for loop. So for I in range, we're going to go from 0, it's the first one. And in Python, we have to go to one more, so then the last one here, so 0 to 15. And that'll let us step through each one of these squares. So hits, we want to add to, but we need to ask the question first, don't we? So we need to say if board at I equivalent to 2, because 2 is the value for a ship that's been hit. Hits equals hits plus 1. So elif, the board at I is exact equivalent to a 1, because that's a ship that's not yet been hit. Then to be hit equals to be hit plus 1. So we've found out now how many things are hit and how many are not hit. So it says we're supposed to output the number of hits. So that's outside this for loop now. So print hits and the variable hits. So we've printed that out. how many hits we've got. So then if to be hit is exact equivalent to 0, we're going to print winner. And that's this bit here. If it's 0 for how many things are yet to be hit, we print winner. Let's give ourselves another line of space here. And elif to be hit is less than or equal to 3. We're going to print almost there. Like that. So that's a 1, 2, or 3, same as saying less than or equal to 3, because if it's 0, it would have done that one already. And that's it. We've finished. There's nothing else to do. So we've done the whole of that. That was quite a big one. It's worth 11 points. We just needed to follow what it was to do and think logically through what we were doing. So the first thing that we did was have this parameter board and the name of our definition. We then had 2 local variables to save the number of hits and the number to be hit into. So then we used a for, so for I in range. See, I've missed an E off the range there. Put it in. For I in range, 0 to 15. If border I is equivalent to 2, so double equals in Python exact equivalence, hits equals hits plus 1, so we're adding 1 to the hit. So it's going to step through all of the boards, starting with 0, then 1, then 2, then 3, etc. and check to see if that's a 1. At the same time, it's going to check to see if that location is not a 1, or sorry, is not a 2. We're going to check to see if it's a 1. And if it is, we'll add 1 to the to be hits. We're then printing out the number of hits, and then we are using another if statement here in order to find out how many things are to be hit yet, and outputting either winner or almost there as a result. So we've sort of done 2 things, 2 if statements here in a similar vein and a for loop. So we've done a fair bit of coding there to get our 11 marks.